Experiment 8. Gravimetric determination of calcium as CaC2O4 H2O. For the first step, weigh around 1.2 to 1.5 gram of dried solid unknown. Add it into a 250 ml beaker. Dissolve the unknown solid in 30 ml of deionized water, followed by adding 12 ml of 3 molar HCl. Stir the mixture with glass rod.
Rinse the 100 ml volumetric flask 3 times with deionized water.
Next, transfer the unknown to a 100 ml volumetric flask.
Rinse the 25 ml transfer pipette with unknown solution.
Transfer exactly 25 ml of unknown to each 3 250 to 400 ml beakers. Dilute each solution with 75 ml of 0.1 molar HCl. Add 5 drops of metal red indicator to each beaker. Add 25 ml of ammonium oxalate to each beaker while stirring with glass rod. Weigh and add 15 gram of solid urea to each sample. Don't forget to weight your filter paper and watch glass. Boil gently the sample until the indicator turns yellow. Place the wash water in ice for the next step. Filter each solution through a weighted funnel.
Add 10 ml ice-cold water to rinse the beaker.
Use a rubber policeman to help transfer the remaining solid to the funnel. Repeat these steps until all the precipitate has been transferred.
Dry the precipitate with aspirator suction for 1 minute.
Put the precipitate into a microwave oven and leave it to dry.
One hour later.
After being dried, take and record the weight of each 3 samples. Don't forget to minus the weight of filter paper and watch glass.
Now presenting is our raw data and all the manual calculations for the data analysis. This includes on finding the molar mass, weight fractions of the calcium, mean, standard deviations, and the relative standard deviations, which has 0.66% and 6.55% respectively, which are both equal to the ones calculated using Excel.
The relative standard deviations for our 3 measurements is noticeably high, indicates that the precision of the experiment is not ideal. The masses obtained 0.52 gram, 0.54 gram, and 0.56 gram spreads out from average value. In gravimetric analysis, relative standard deviation less than 1% indicates very high precision, while relative standard deviation 1 to 5% is a good precision. However, a 6.55% of relative standard deviation obtained, which is slightly higher, suggests that variations occur during the procedure. This variation may be rooted by several factors such as partial loss of the precipitate, incomplete precipitation, inconsistent drying, or the presence of impurities. Technique used during filtration and transfer may also contribute. To achieve better precision, extra attention should be given to ensure complete precipitation, careful filtration, through washing and drying the precipitate to a constant mass. In this experiment, calcium was successfully precipitated as calcium oxalate monohydrate, and the average mass from the 3 trials gave an estimate of the calcium content in the sample. However, the overall precision was not very strong. The relatively high RSD shows that the 3 mass 0.52 gram, 0.54 gram, and 0.59 gram differ from than what it is normally expected for a gravimetric analysis. This variation suggests that several experimental errors may have occurred, such as incomplete drying, loss of precipitate during filtration, or minor contamination. Because of these inconsistencies, the average value obtained is not highly dependable for representing the true calcium content. More trials and better control of technique would be needed to produce more reliable results.